Well, hello everyone, this is Mr. Reeves, and I'm here with you today to work through the CAASPP practice test for 8th grade math. We're going to be breaking it up into 5 questions at a time. So today we're going to start by getting into the practice test, and then we're going to do the first 5 questions. So I've gone to the CAASPP practice test site, and now I'm going to go ahead and press on the green button to get us started. We're going to just sign in as a guest. And then, of course, today we're going to be doing 8th grade. Right here, I'm going to select the 8th grade math practice test. Keep all the defaults there. Go ahead and do the video check. Sounds good. Keep those as they are. And now we're ready to go ahead and get started. So question number 1 says, enter the value of n for the equation 5 to the n equals 5 to the 11th times 5 to the 3rd. So let's go back and think about something that we learned earlier this year. We learned that x to the a times x to the b is x to the, not a times b like you might think, it's x to the a plus b. Notice the bases are the same, and then we take these two and we add them together. So I got to be honest with you, many times my students would do this problem and they would go 5 times 5 is 25 and 11 times 3 is 33, and they would say the answer is 25 to the 33rd, which doesn't make sense if you think about it, because that would be 25 times 25 times 25 all the way up 33 times, and that would be way too big. So if we use this rule up here, the product rule for powers, we're going to keep the base the same. So 5 to the 11th power is 5 times 5 times 5, 11 times. 5 to the 3rd is 5 times 5 times 5. So the base stays 5. And again, we don't multiply, we add, and we get 14. So 5 to the 11th times 5 to the 3rd is 5 to the 14th. Now, if you read the problem carefully, they only asked for n. So all we're asked for is that exponent 14. So the answer we're looking for on number 1 is 14. Let's go ahead and go to the next question. This one's a little bit more involved here. It says the distance d in meters a car travels in t seconds is shown in the table. So here we have the time, that's over here in seconds. Here we have the distance, that's right here. So the time is on the x-axis, which is t, and distance is on the y-axis. Really would be nice if they switched these around, because usually we have the x-axis here and the y-axis here. But let's just take a look at that. It says use the add arrow tool to graph the proportional relationship between distance traveled and time. All right, so if we were just going to do this by hand, I would just go ahead and say, okay, so the first time is 1, and the distance would be 10. And the second time is 2, and the distance is 20, and then 30. And you can see it's a linear relationship that is also proportional, because if I connect these with a line, it's going to pass through 0, 0. So we have a linear relationship that passes through the origin. So that means it is proportional. In fact, we could find the value of k, because k is equal to y divided by x. So if we took any of these points, for example, this one right here, we could do 50 divided by 5, and we would get 10. So the equation of that line would be y equals 10x. But that's way more than they asked us to do. What they actually asked us to do was to use the add arrow tool to graph it. So I'm going to go ahead and grab this add arrow tool, and I'm going to put a point at 0, 0. And then I'm going to go right up through 50, 10. So there we go. All right. Okay, and that's all they asked us to do. So let's go ahead and go to the next question. All right, here we go. Select true or false to indicate whether each comparison is true. All right, so we got some work cut out for us now because we're asked to compare each of these. All right, so just a reminder, let's take a look at these symbols. These are inequality symbols. Let's remind ourselves of what they mean. That one right there means is less than. So the number that comes first is less than the number that comes second. That's why this is opened wider. A lot of you learned the whole alligator mouth thing, right? You made it into a mouth. Anyways, so that one is less than. Of course, the one going the other direction means is greater than, because in this case, the larger number is coming first. I always said the smaller one eats the bigger one. That never made sense to me. How could the smaller one eat the bigger one? Anyways, if the bigger part comes second, it's less than. If the bigger part comes first, it's greater than. So that's the first thing we need to be reminded of. All right, so we're not going to use a calculator on these, so we're going to have to do our best here. And I think estimates are probably going to do us pretty well here. So let's take a look at this first one. That symbol means the square root of 37. Now 37 is not a perfect square, but 36 is. Square root of 36 is 6. So the square root of 37 is just going to be a little bit bigger than 6. So I'm going to put 6 plus right here. Well, this number right here is 5 and 1/4. So let me ask you, is 6 less than 5 and 1/4, or a number actually a little bit bigger than 6? And the answer, of course, to that is no. So for this first one, we would mark false. All right, you guys remember that one for me. The first one's false. All right, now let's take a look at this next one. 3 times pi is greater than 3 times the square root of 3. All right, something to notice right here. Both of these have the number 3. So 3 pi means 3 times pi. And 3 square root of 3 means 3 times the square root of 3. So since these both are 3, those parts really don't affect the answer. What we really have to compare is how does pi compare to the square root of 3? Now, when I ask my students, what is pi? Many times I hear pi is equal to 3.14, which of course is not true because pi is an irrational number. It goes on for ever and ever and ever. I don't know that pi is any better than my first one. So pi is approximately 3.14159. All right, we don't have to know it exactly at all. All right, the square root of 3 is not a perfect square. The square root of 3 is between the square root of 2, which is also not a perfect square, and the square root of 4, which is a perfect square. The square root of 4 is 2. In fact, if we go down, the square root of 1 would be the perfect square that's below it. So the square root of 3 is between 1 and 2. It's between 1 and 2. So I want you to think about this. Pi is 3.14159. The square root of 3 is between 1 and 2. A lot of times people want to say 1.5. It's actually a little closer, but let's say, I don't know, maybe about 1.7. All right. So how does pi compare to square root of 3? Well, pi is definitely bigger. So is 3 times pi greater than 3 times square root of 3? The answer to that one is yes. So that one is true. All right, let's take a look at the next one. Square root of 5 compared to 5/7. All right. This one, if you know what you're doing, is actually pretty darn easy. Because in a fraction, the top number tells you how many you have, and the bottom number tells you how many to make a whole. That would be a W whole, right? How many you have versus how many to make a whole. So if I have 5/7, I need 7 to make a whole, and I only have 5. So what does that mean about that number? That means that it is less than 1. In fact, anytime the top number is smaller than the bottom number, the fraction is going to be less than 1. So this number is smaller than 1. Square root of 5, again, the square root of 5 is not a perfect square, but the square root of 4 is. And the square root of 4 is 2. And the next bigger square root is square root of 9, perfect square that is 3. So the square root of 5 is between 2 and 3. So definitely bigger than a number that is less than 1. So this one is also true. So if I were a betting man, I'd guess that the last one's going to be false, but we're not gonna guess. We're going to do the math. All right, so here we go again. So 8.38. Not much we can do with that one. Let's take a look at this at 15 divided by the square root of 10. All right, so we're going to find out this one's not so bad either. So again, let's take a look at the square root of 10. So square root of 10, not a perfect square. But the square root of 10 is between the square root of 9, which is 3, and the square root of 16, which is 4. So let's think about this. We're taking the number 15 and we're dividing it by a number that's between 3 and 4. In fact, it's just barely above 3. So let me ask you, if we just estimate, what's 15 divided by 3? 15 divided by 3 is what, guys? It's 5, right? So this number is actually going to be a little bit smaller than 5 because this that we're dividing by is a little bit bigger than 3. So a number a little bit smaller than 5 is greater than 8.38? I don't think so. All right, so there we go. So it took a little bit of work, a little bit of estimating, but nothing too crazy. All just based on estimations. We didn't have to know anything exactly here at all. So we got false, true, true, and then false. False, true, true, false. Hit them all. And we're ready for the next question. All right, select all the possible values for x in the equation. Wow, this one looks really scary. X to the third equals 375. So that means x times x times x is equal to 375. All right, now, if it were x plus x equaled 375, then we could simply divide by 3, right? Because that would be 3x equals 375. And we could divide by 3, and we would get x is equal to 125. But notice, that's if you're what? You're adding. Do you agree that 125 times 125 times 125 is not going to be 375? That would be way too big over here, right? Or 375 would be way too small. So the question is then, if you have x times x times x is 375, you can't divide by 3. What do? And the answer is you take the cube root. So the cube root of 375 is what we are looking for. The cube root of x cubed is going to give us x. So x is the cube root of 375. Do you see that answer there? I do. But look carefully. If you look at the instructions, it says to select all the possible values. So that means there's probably another one of these answers that is correct. Now, let's take a look at this number 375. I can break 375 into 3 times 125. And you might say, well, how is that helpful? Well, it's helpful in this way because 125 is 5 times 5 times 5, right? 5 times 5 is 25. So the cube root of 375 is equal to the cube root of 3 times 5 times 5 times 5. But what does the cube root say? It says what times itself, or what do you have the same thing multiplied 3 of them to get that number? And that means that 125 is a perfect square. So I can rewrite this as the cube root of 3 times the cube root of 125, but the cube root of 125 is 5. And then I'm going to go ahead and take that number and move it to the front because it's a coefficient. And I get 5 times the cube root of 125, which is right. No, excuse me, my bad. Not 5 times the cube root of 125, 5 times the cube root of 3. That's better. Okay. All right, so these ones would not work, all right, because this would imply that I had the cube root of 5 times 75 times 75 times 75, and that's going to be way too big. And this one would be even bigger because this one would imply I had the cube root of 3 times 125 times 125 times 125, which would also be much, much bigger than 375. All right, so we were looking for the first 2 on that one. All right, the last question for today, question number 5. Determine whether it's rational or irrational. All right, so you have no idea how to answer this question unless you know what rational and irrational means. So let's revisit that. A rational number is any number that can be written as a fraction, a over b, where a and b are integers. And of course, b cannot equal 0 because you can't divide by 0. So basically, if you can write it as a fraction, where each of these is an integer value, and this one's not 0, it's rational, okay? Irrational numbers cannot be written like fractions. And a way to recognize an irrational number, we say it is non-terminating. That means it's going to go on forever and ever and ever and ever. And it is non-repeating. So a perfect example of an irrational number is pi. Pi goes on forever and ever and ever and ever, and it never repeats. Now, by not repeating, it never repeats a pattern. We only have 10 digits in our number system, so the digits have to repeat, but there's not a pattern. So pi is an example. The square root of 5 or any square root of any number that's not a perfect square, square root of 11, things like that. Those are common irrational numbers. So let's take a look at what we have. The first one, 1 over the square root of 9. Well, we were talking just a little while ago about square roots. The square root of 9 is 3. So when we simplify 1 over the square root of 9, we get 1 over 3, which according to our definition is rational. All right, square root of 17, that's what I was just talking about. It is a square root of a number that is not a perfect square. Those are always going to be irrational. All right, let's take a look at -1 and 2/3. Now, 2/3 is kind of tricky because if you have memorized your fraction to decimal conversions for those special cases, you should know that 2/3 is 0.66666 ... forever, which we usually write as 0.6. Repeating, which means it is non-terminating. But guess what? What does it do? It repeats. So while it does meet one condition for irrational, it doesn't meet the other one. All right. And the other way to think about this is I could change this to a fraction. This is not a fraction, by the way. People mistakenly call this a fraction. This is a mixed number. I can go 3 times 1 is 3. 3 wholes plus 2 extras. This can be written as -5/3, which of course makes it rational. And right here we have a decimal, 0.423. Is it non-terminating? No, it terminates. So right off the bat, we know it is rational. By the way, we could also write 0.423 as 423 over 1,000, which lets us know that it is rational. So what do we got? We got rational, irrational, rational, and rational. And that completes the first 5 questions of the CAASPP Math 8 Practice Test. We'll come back later and continue from here.